Hello Year 11 and welcome to our 11th and last video for our 10th topic here. We're looking at the volume and surface area of composite solids today that are some solids that maybe have bits chopped off or added to them, probably two solids joined together. Now the main thing that I'm going to talk about here is the volume of a composite solid, straightforward enough. You add or subtract the individual volumes. However, the surface area, not quite so simple. When I join two solids together, the surface area will be the sum of the original surface areas minus twice the area that they overlap. Okay? When they join together, some of the surface area sort of disappears, is no longer on the surface. And there's that shape or that area on each of the solids. So we have to take it away twice. Anyway, we have a volume question to do here, and I don't have a diagram. So let's read the question carefully, and I think we'll draw a diagram. A swimming pool, it's 50 meters long, 25 meters wide. Sounds regular enough. Okay, but what's happening here? It has a uniform depth of 1 meter for half its length, and then gradually increases to 2 meters deep at the end. So I think we have something like, I'm going to exaggerate things a lot here, this going on. Oops. Well, I've made a bit of a mess there, haven't I? Oh well. Righto. So, I have a prism of sorts, and on the side of my prism, right, the area part of my prism, is this shape. Right, and I'm just going to redraw that shape, and it's going to look like this. I'm going to draw a little dotted line here. Okay, so that's 1 meter. That's a 1 there. That's a 2 there. This is 25 for its half its length. And this is a 25 here. Okay, now over here, yeah, that's a 25. 50 here. Okay. So, when I'm working out the volume, the first thing I need to do for a prism is work out the area of the base. And I have two different shapes here, a rectangle, and this here, can we see that it is a trapezium? Okay, I've got a pair of parallel sides. So, my area equals 1 times 25, that's the area of the rectangle on the left, plus, now the average of my my parallel sides, 1 plus 2 over 2, times the distance between them, which is 25. So my area here is 25 plus 1.5, lots of 25, I think must be, what do I feel like that should be? 62, I think it's 62.5 square meters. Yeah. That is the area of, right, my base, if you like, which is sort of this part here that we've just worked out. That's my 62.5. Now to work out the volume, right, the volume is the area times the height. So my volume equals 62.5 times my height, right, that's how far apart the parallel sides, or the parallel surfaces are, that's times 25 again in this case. And I'll need to pull out the calculator now. Okay, so the volume of my pool in cubic meters, where is my cursor? Here it is. Oh, I've lost my pen. Okay, the volume of the pool is 1,562.5 cubic meters. Right, so that's 1,562 kiloliters, or 1.5 megaliters. Okay, that's how much water we would need to fill the pool. Now moving along, the sides and floor of the pool would be tiled at a cost of 100 square meters. How much will it cost to tile the pool? Well, what we're really looking at here is the surface area less the top. Okay, so I don't want the top surface here, that's not going to be tiled, but I need the other ones. Now I have two of these shapes, and that's pretty good because I know the area of this. I've worked it out, and that's 62.5. So I've got a 62.5 here and a 62.5 here at the back here. I've got a rectangle here, which is going to be, right, that's 25 times 1, that's good. And another rectangle on this end, that's 25 times 2. So I now have 4 of those faces. But consider the tiles along here. I have, right, the flat part of the bottom, the non-sloping part of the bottom of the pool, has an area of 25 times 25. Okay, 25 times 25. That's easy enough to work out. There's a square there, 25 by 25. But this slopey bottom of the pool, that's not 25 long because it's on the slope. It's a little longer. Not a lot longer, but a little longer. So, let's consider this. I have, let's just draw this for the time being. So badly out of scale. Now I know that's a 1 there. That's a 2 here. It's a 2 there, and it's a 25 here. Now I really need to know how long this side here is. I'm going to call it X. And I think if I put another little dotted line across here, then I can see that's a 1. Right, that's a 1 there. That's a 25 here. So I can use Pythagoras' theorem and say x squared equals 25 squared plus 1 squared. Means that x equals, so here, let's pull the calculator up onto the screen. Clear that last one off. I have 25 squared plus 1 squared, which is just 1, save myself the time, equals this. And the square root of that is going to be very close to 25. But nonetheless, of my answer, the square root of the last answer is 25.02. Quite close, 25.02. Okay, now that might just be enough to have some impact on the answer. So 25.02 meters. Now my surface area. Can we remember all of the different things? There are there are my sides, 62.5. 2 of those. Okay, there's the wall at the shallow end, which is 1 by 25. There's the wall at the deep end, which is 1 by, oh, it's not 1 by, it's 2 by 25. I'm going to have to shuffle across a bit. Now, there is the floor of the shallow end, which is 25 by 25, and the floor of the deep end, which is 25.02 by 25. Oh, and I've just ran out of space. Now I'll need to work each of those out. Right. Let's actually just tidy it up a little bit. So that's going to be 125 here. Okay, 125 plus 25 plus, oh, that says times there. That should be a plus. That's some sloppy work. Plus 50 plus, now 25 times 25 is 625. Now 25.02 times 25, it's not going to be very much bigger. Okay, 625.5, so half a square meter bigger. Plus 625.5. That's quite close enough, I think. Now, we can probably add these up. 125 and 25 is 150. 200. 825. 800. 1,450.5. 1,450.5 square meters. Now, $100 per square meter. Therefore, oh, my cost equals 1,450.5 times $100 equals, right, I can just move the decimal place 2 spots. So right is $145,050. That's quite a lot. $100 a square meter. Maybe that's what it costs. Maybe it's not. Who knows? But that's how we answer this question. A little bit tricky there, and that's why the video's got away from us a little. A little bit tricky that we had to work out various things, and that's the nature of this last exercise. Composite areas and volumes and surface areas. An additional sketch really helps a lot of the time. Okay, if I can stress that, to make a sketch is very important. It's not at all uncommon that you might have to use Pythagoras' theorem to find an extra dimension for something. Okay, and just keep an eye out for combining solids together, right, that we don't just add the 2 independent surface areas. Okay, be careful about where 2 solids might overlap, and part of the original surface area is no longer on the surface. Rightio, that's it for this exercise. That's it for this topic on measurement. Okay, I hope that it's made enough sense. If you've got any questions, I'll see you in class.